Hello all. Today we are going to see the software engineering and project management basics. Introduction to software engineering and project management. In this lecture, we'll be introducing what is software to you first. Software is a product or a path towards a product. The product that the software professionals build and then the software over the long term. Always the software encompasses instructions, data structures, and documentation. What is instructions? Instructions are computed programs that can be executed, which provides the desired features, functions, and performance. Then, data structures enable the programs to be adequately stored and to be manipulated the information along with the adequate storage. Documentation describes the operations and usage of the programs. That is why always the software means instructions, data structures, and documentations. Now, let us see what are the features of the software. The features of the software are different from that of the features of human beings. Yes, software should be a well developed or an engineered one. It is not just a manufactured just like a classical sense, it has to be with the better quality. If it does not have a proper quality, then it means it is like slowly deteriorating due to the change. It doesn't mean it is completely weird out, but it starts deteriorating because of several changes. Then, software, if you look into software, it is different from hardware. Hardware has a bathtub curve of the failure rate, that is, high failure rate in the beginning, then drops to the steady state. Then, cumulative effects of the dust, vibration, abuse that occurs. Although the industry is moving towards the component based construction, that is, it starts with the software which continues to build up. The modern reusable components encapsulates and the data is being engineered and processed. If you see, the software has different types such as system software, application software, scientific or engineering software, embedded software, product line software, web apps, and the AI-built software. System software are nothing but compilers, editors, and file management utilities. Application software are standalone programs which is being built for specific needs. Engineering softwares are characterized by number crunching algorithms such as automative stress analysis, molecular biology, and orbital dynamics. The embedded software always resides within the product or a system. That is, it can be a microwave oven or a digital function of a dashboard display in a car. The product line software always focuses on a limited marketplace in order to address the mass consumer market. Web applications are important. That is, even after the Web 2.2 has emerged, it has been completely sophisticated with computing environments, which is supported by the remote database and the business applications. Finally, it is even the AI-based software, which solves complex programs like robotics, expert system, pattern recognitions, which is being used for even gameplay. Software process is a collection of activities, actions that takes place along with several more actions that has to be performed within a timeline because the end product should be a software and it has to be delivered within the timeline. That is why always it is a process of several activities, a collection of activities, so that each action has to be completed within the time. Software project management, if you take, a project is a well defined task which is a collection of several operations done in order to achieve a goal. Here, if you see, every project has its own unique and distinct goal. Yes, it should have a start time and end time. Anyhow, it should have a proper routine, not day to day operations, but a proper routine. It should have a start line, and the final goal should be achieved at the end time. Hence, if you see, the final goal should be an achievable one within the deadline. The project needs adequate resources in order to achieve such a goal in terms of time, manpower, finance, that is budget, materials, and even the knowledge. Yes, software project management, if you see, it has a proper life cycle. The phases are initiation, planning, execution, monitoring, and closure. Initiation is nothing but getting the requirements. After getting the requirements from the customer, we have to plan accordingly. That is, which phase has to be done. Yes, where we have to start and where should we end within the timeline. And it has to be executed properly. And we have to even monitor whether it has been executed correctly or not. Finally, the project has to be delivered within the timeline. If you see, the activities encompasses an important thing, that is starting from planning, deciding the scope of the project, estimating the cost, budget, and even the timeline, resources to be used in terms of scheduling of all these tasks. So it is an umbrella activity. And the list of activities encompasses are the following, that is starting with planning, tracking, resource management, scope management, estimation, project risk management, scheduling management, project communication management, and the configuration management. In this, if you see, it starts with the planning. Here, the planning is nothing but we get the requirements. We get the requirements from the customers, and it has to be planned properly of which has to be taken care of first. In this, if you see, the planned steps has to be tracked correctly, which is more important because the resources have to be managed properly and the scope of the project has to be identified and it has to be followed accordingly. Importantly, the estimation is much more here to be needed because estimating the timeline, budget, resources not only the software resources, also the human resources. It's very primary. That is why estimation management is very important. Also, scheduling all these phases are very important because achieving the complete product within the deadline is primary, within the resources is also important. That is why scheduling management is under the list of activities. And all these have to be communicated then and there to your stakeholder. And if there are some gaps, we have to try to solve it. Finally, even it has to be configured and managed accordingly. The updations should be given accordingly. So these are the list of activities under a software. If you see this SEPM life cycle, that is software management life cycle, has, that is SDLC, people call it software defined or software development life cycle. Here there are 7 phases. It is a structured framework for planning, execution, and maintaining software. That is, the planning phase is very important where we get the requirements, right? The requirements have to be got from the stakeholders in the beginning itself, which is more important. And hence, this has to be like advantageous where we have to maintain the collaboration within the team formations. That is why planning is more important. Now let us see what is this process. A process defines who is doing what, when, and how, so that we reach our goal, a final goal within the timeline. This has to be done to complete the software process, regardless of what is the size of your project or how much the project is complex. It encompasses several umbrella activities within the timeline. The umbrella activities are nothing but set of actions. It is a collection of related tasks. The framework has a collection of related tasks. Each action has an individual work, that is task. Now let us see what are the umbrella activities. First thing is communication. Next it is planning. Next modeling, construction and deployment. Communication is getting the requirements, gathering the requirements from your stakeholder or customer. And we have to communicate that to our team. That is communication. Requirement gathering and related activities comes under your communication. Next, planning. Planning is once after the communication is done, we got the requirements, we have to sit plan. That is planning in the sense what has to be followed first, what can be the risk if you follow this step first. And all these have to be estimated. That is the time, budget, human resources, workforce, and the products that will be actually finally produced once after we follow the schedule. All these should be planned. The workflow has to be planned. Then modeling. Modeling can be done under low fidelity or high fidelity. A paper design or using a high fidelity tools, right? CAD tools or any other tools, right? We can use it. That is modeling because our important criteria is our customer have to understand what is the requirements they have given and whether we have satisfied those requirements. That can be done using the modeling only. Analysis of requirements can be done using modeling. Then construction is code construction. Source code construction, which can be done either manually or automated or even the combination of both. Once after the coding is done, we have to validate it. Testing has to be done. Validation is not only just identifying the errors and like correcting the errors. Also, we are going to check whether the final product is the one which the customer has narrated, is the one which the customer wants, has been required, right? So that is validation. Finally, it has to be delivered to the customer. That is deployment. And once after the delivery is done, we have to get the feedback of the customer. There ends the framework activities of a simple software development life cycle. If you see, this is an umbrella activity where adequate actions have to be taken. And maintaining the schedule is very important because assessing the progress against the project plan is much essential in a software development life cycle. This can be done after getting the reviews, technical reviews of the team, so that if there are some errors, we can recover that from those errors before it moves to the next action or activity. And the quality have to be maintained. Finally, we have to ensure the product is of good quality and which can be even upgraded towards its management. The documentation is very important because documenting each step using logs, forms, lists are priorly to be done till the final date because this will be important for the next process, that is even for the upgradation. Reusability of the components and even the code is much more important. That is why reusability management is a part of the umbrella activities. And maintaining the customer needs. Also, just by measuring what is the customer need and whether we have delivered that or not is much more important along with risk management. Because identifying the risk and assessing the risk have to be done in this umbrella activities even. Software process models are adapted always to meet the needs of software engineers and managers for a specific project. That is why always a process model is not perfect, but it has to be engineered with high quality software. That is important. And to have this, a software process model always have a proper framework. The activities should follow communication, planning, modeling, construction, and deployment. These steps are important in any software development life cycle. Communication is the initial requirement gathering. Once after the requirements are gathered from the customer or the stakeholder, then our planning should start. That is, time estimation, project timeline has to be made, budget has to be estimated, how many resources, what are the resources, all these have to be estimated under the planning. Once after the planning is done, we have to start modeling. And the modeling or the analysis design is very important in order to understand what the customer has told. Also, after the design is made, we can communicate that again to the customer. Then the code construction will start, coding and testing will be happening. Finally, we will deliver the product to the customer, that is deployment. This is what is called as prescriptive model. Prescriptive model always has a recommendation of set of activities that has to be done within the timeline. This follows all these steps. So that is the requirement analysis, scheduling and tracking, system and software design, integration, that is coding and testing. Finally, it is operation and maintenance. Yes, but even after following all these steps, what are the limitations in using such a conventional software development lifecycle step? First thing is, always in the initial stage itself, a customer will not just give the requirements. Maybe in the middle also, the customer can have different idea. They can give some more features to be added, but that will not be included under such a conventional software development lifecycle phases. It does not account for the fact that always the requirements will not have changes at all. It will constantly change, right? It will be changing. And if it is going to change, this will not be achieved using the conventional life cycle. Other one thing is the final steps. That is, once after completing every step, only we can move to the next step. But this will be always expensive. And if the customer comes and asks you for changing or adding some more features, again, this will not happen in the conventional model, which is not appropriate when the requirements are well understood and it can change here and there. That is why real time projects are rarely followed by such sequential or waterfall or conventional software development lifecycle model. And here it is very difficult for the customer to state all the requirements explicitly at the beginning itself. So this will not happen with respect to the real time projects. That is why we have to move to some other idea. So there came an idea of agility practices, which we will see in the next upcoming lectures. So in the next lecture, we will discuss about how to communicate the requirements, right? How a stakeholder will communicate the requirement and why there can be some changes here and there and which expects a agility model. So that is our next lecture. Let's see in the next lecture.